So here is the trapezium rule. A version of it will be given to you in your formula book. And it's really useful for estimating the area under a complicated looking curve. It works by splitting the area up into different strips or trapeziums and then finding the area of all of those trapeziums and adding them up. You could do that process by hand, but using the trapezium rule formula makes it a lot easier and quicker. I just want to point out a few key things on the formula before we do an example. First thing is A and B are your limits of integration. And on the diagram here, that would represent the two boundaries that you want to integrate between. You use those limits here when you're working out h. And h is actually the height of each trapezium. If you turn your head to the side and look at these trapeziums on the sketch, these are, in fact, the heights of each trapezium. And you work it out by doing the difference between the limits divided by n, where n is the number of strips or trapeziums that you want to use. Now, in general, the more strips or trapeziums that you use, the more accurate your estimate will be. If I was to split this sketch into even smaller trapeziums, you'll see that they would be more closely aligned with the curve shape. And the more you use, even more closely aligned it will be. So now we've had a look at the idea of the trapezium rule, let's look at an example. This says use the trapezium rule with 4 strips to estimate the value of this. So we know we want 4 strips, which means in the trapezium rule formula, n will be 4. So the first thing I do is work out the height of each trapezium. So I'll do h equals the limits subtracted from each other, so 3 take away 1, divided by the 4 strips, which gives us a half. So in this case, h is a half. And you don't have to, but I find it really useful to then draw a sketch. I'm not suggesting we need to know what x ln x plus 1 looks like in a sketch. I just mean a generic shape, maybe something like this. Reason being, I like to visualize the area that I'm finding. So I know I want the area between 1 and 3. I know I want 4 strips. And I also know that the height of each trapezium is a half. So that means I can break this down and I know that each of the x values I'm going to be looking at are 1, 1.5, 2, 2.5, and 3. That way I can sense check that I haven't made a mistake when I've been calculating h. Because h turned out to be a half or 0.5 and that matches the sketch. Once we've done that, the next step would be something like drawing a table of values to help you. So if we do x values and y values in a table, I use my sketch and I see that the x values I'm interested in are 1, 1.5, 2, 2.5, and 3. I then find the matching y values. We get those by just subbing into the function or expression that's inside the integral. So in this case, it's x ln x plus 1. So when x is 1, y would be 1 ln 2. When x is 1.5, it's going to be 1.5 ln 2.5, and so on. So again, I'm just getting that from the expression inside the integral there. Now, the reason we need the table of values is because we need those individual y values to put into the trapezium rule formula. It works like this. So the first x value is denoted as x0, which means the first y value is y0. We then go up x1, x2, x3, x4, and then y1, y2, y3, y4. This will help us to see what we need to put in the formula where, because the formula says that we're going to do half times h times y0 plus yn. So in this case, that's going to be our y0, which is 1 ln 2, plus yn, y4, 3 ln 4, plus 2 times all of the other y values. So y1 being this, y2 being this, and so on. Once you've identified those values, it's just a case of subbing them into your calculator really carefully. So I'd write out the full formula on my paper. So we want to do a half times h, which is also a half in this case. Big brackets, y0 plus yn. So in this case, 1 ln 2 plus 3 ln 4, plus 2 times all the rest. If you type that into your calculator, you get 4.56 units squared, corrected 3 significant figures. That's it for now. If you found this video useful, please do remember to like, comment, and subscribe to my channel if you haven't already. And do share this with anyone else you think might find it helpful. Thanks, and see you next time.